look great from here. Glad to see you.
Hello, Yogi. Nice to see you too. You look good too today. How is Jakarta today?
Okay, nice, very nice.
Okay.
Thank you. The 14th ECM, or International Seminar on Industrial Engineering and Management, is hosted by 8 universities, which are Universitas Al-Azhar Indonesia, Universitas Trisakti, Universitas Esa Unggul, Universitas Pasundan, Universitas Tarumanagara, Atmajaya Catholic University of Indonesia, Universitas Pancasila, and Telkom University. And this also the third year's our International Partnership Joint Committee with Chung-Yuan Christian University Taiwan and Kasetsart University Thailand. And we would like special gratitude thanks for our sponsorship, Board of Industrial Engineering Chapter, the Institute of Indonesian Engineers, BKTI, PII, and also please welcome to all Dean of 8 University Joint Partnership Committee. Ladies and gentlemen, let's give gratitude special thanks and please welcome all keynote speakers at Jakarta, Indonesia site, Professor Matteo Savino, Professor of Industrial Operation and Industrial Management, University of Sannio, Italy. And honorable guest, Rector of University Al-Azhar Indonesia, Professor Dr. Insinyur Asep Saifuddin, MSc. Welcome. And Chairman Board of Industrial Engineering Chapter, the Institute of Indonesian Engineers, Insinyur Faisal Safa STM SCIPU, ASEAN Engineer. Professor Awaluddin Mohammed Saharun from Faculty of Engineering, Department of Mechanical Engineering, Islamic University of Madinah, Saudi Arabia. And also keynote speakers in Taiwan side, please, Riana.
Good morning, ladies and gentlemen. Thank you, Yogi, for the opportunity to present the presenters and also VIP people from Taiwan. Good morning, ladies and gentlemen. Good morning to our honorable and respectable guests, the Dean of Electrical Engineering and Computer Science College, Chair of Industrial and Systems Engineering Department of Chung-Yuan Christian University, Professor Yung San Cho, to the respected ECM committee from Jakarta, Indonesia, Dr. Fifi Trianti, Dr. Christy Natalia, Dr. Rahmi Maulida, and also Dr. Ipov Kumala Sriwana. We would also like to greet the respected ECM partner from Kasetsart University, Thailand, Dr. Nauporn Prauprazar, Dr. Papis, and also Pongton. Welcome. We would also like to invite and welcome respected keynote speakers from Taiwan, Mr. Stephen Lin, MBA, the director and also founder of Motion Tech Group, Professor Ping Sun Chen, professor from the Department of Industrial and Systems Engineering Department, Chung-Yuan Christian University of Taiwan. We would also like to welcome the Dean of Electrical Engineering and Computer Science College of Chung-Yuan Christian University, Professor Cheng Yuan Chang. Welcome. Welcome to the 14th International Seminar on Industrial Engineering and Management, live from CUSU, Taiwan.
Thank you, Riana from Taiwan. Ladies and gentlemen, honorable guests, today we have several agendas. Allow me to inform you general rundown of the seminar agendas. The first is the opening of 14th International Seminar of Industrial Engineering and Management 2023. Secondly, listening the Indonesia and Taiwan National Anthem. Thirdly, is opening speech and partnership ceremony. Fourthly, presentation of all keynote speakers and photo session. And the last agenda is parallel session and closing of the opening ceremony of 14th ECM 2023. And we would like to inform all participants at Grandika Iskandar Shah Hotel Jakarta of the prayer room, restroom, and smoking room to the left of the entrance to the seminar room. Thank you. Ladies and gentlemen, honorable guests, please rise for the Indonesia and Taiwan national anthem.
For audience in Taiwan, please arise also to honor the national anthem from Indonesia and also Taiwan.
Please be seated. Thank you. Ladies and gentlemen, honorable guests, we have now come to the greeting speech. Please welcome the chairman of 14 EZM, Dr. Nunung Nur Hasanah, from University Al-Azhar, Indonesia. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, dear honored guests, delegates, and colleagues. On behalf of the organizing committee, I'm honored as the chairman of this international seminar on industrial engineering and management to welcome you to this event. Please welcome our colleagues from University of Al-Azhar Indonesia, Trisakti University, Esa Unggul University, Atmajaya Catholic University of Indonesia, Universitas Tarumanagara, Universitas Pasundan, and Telkom University. And please welcome our international partnership from Chungyuan Christian University and Katsetsart University. Our sponsor from the Institution of Engineer Indonesia, Industrial Engineering Chapter, and our supporter from Indonesian Association of Industrial Engineering Higher Education. And also our keynote speaker and Rector of University of Al-Azhar Indonesia, Prof. Asep Saifuddin. The purpose of this seminar is to provide an effective forum for distinguished invited speakers, academicians, engineers, professionals, and practitioners coming from university, research institutions, government agencies, and industries to share or exchange their ideas, experience, and recent progress in industrial engineering and management and other related fields in dealing with the dynamic and challenges of the VUCA. This seminar is also expected to foster networking, collaboration, and joint efforts among the conference participants to advance the theory and practice, as well as to identify major trends in industrial engineering and management field. The main theme of this seminar is collaboration and resilience towards sustainable industries. Under this theme, we will explore the collaboration in industrial technology, information, and management concerning global issues. We also discuss approaches to collect, manage, and use any information efficiently and effectively. Thus, the result will be able to upgrade industrial competitiveness and value in facing the global challenges in industrial environment. And I also want to report this year we received 117 paper submission from various national and international university, research center, and its affiliation. Our committee editors accepted 111 selected papers that will be presented in this seminar. These selected papers are categorized into 8 groups. There are, the first is decision analysis and information system. There are 11 papers. From operation research, 12 papers. From supply chain management, 10 papers. From industrial system, 12 papers. From ergonomics and product design, 23 papers. Quality engineering and management, 22 papers. Entrepreneur and technopreneur, 7 papers. And the last is from production system. There are 6 papers. The accepted papers are from authors from Indonesia, Taiwan, Thailand, United Kingdom, Germany, Korea, and India. Our reviewers come from 10 national university and 6 international university, namely from IPB University, University of Exeter, Postmon University, University of Campania Luigi Vanvitelli, Italy, Wuhan University of Technology, University Malaysia Pahang. And finally, the success of this seminar is due to the hard efforts of many people who are gratefully acknowledged. We also thank the authors whose papers are presented, invited keynote speakers, and all parties that we are not able to mention here. We hope you all will enjoy the discussion and gain maximum benefit through this seminar. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
GM, Dr. Nunung. Ladies and gentlemen, honorable guests, we have now come to the opening speech. Please welcome Rector of University Al-Azhar Indonesia, Professor Dr. Asep Saifuddin, and please to officially open this seminar.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, both in this room as well as in the virtual room. I'm very pleased to be here as a rector of Al-Azhar Indonesia University to open this very important event organized by University of Al-Azhar Indonesia, as well as the committee in Indonesia, such as Trisakti University, SH Unggul University, Tarumanagara, Unpas, Pasunan in Bandung, Telkom University in Bandung, and also Pancasila University here in Jakarta, as well as Atma Jaya University. I am very thankful to all the leaders of this university. After several years, I think we cannot see them due to COVID pandemic. And I am also glad that this event organized also with the international university in Taiwan, especially Taiwan Aichung Chung Yuan Christian University. Thank you very much for having us here. Then for sure, Ibu Nunung, thank you very much for organizing this 14th ECM. It's already 14th time, I believe, to organize the international conference on industrial engineering and management. As we are in the academic side, we cannot stay alone without collaboration with other partners from other sectors. And also, I heard that we will have a keynote speaker from Italy. We have here Professor Matteo Savino. Thank you very much, Professor Savino, who come here with your wife, I believe, and thank you very much. I hope you enjoy Jakarta with the busy traffic. I came from Bogor 6 o'clock. Actually, usually in 1 hour and a half, but every Monday it is more crowded. Monday, many truck this morning, and so I came in 2 hours. Usually I came 6 o'clock to my campus, 7 o'clock 30 already in campus. But today, a little bit late. I'm very sorry about this one to the organizing committee. Although it's not too late, but still late, yeah. But people say better late than never. So I'm here. Also, I would like to give a probably not too important topic for you, as you are in industrial engineering and management. I am a statistician, but from perspective of statistics, I understand that now the world is changing very fast due to the technology, information technology, IoT, and my part is big data, not anymore small data. Perhaps we understand when we took class of statistics in first 2 semester, that time we have problems with small data. How to conclude something when the data is not enough? How can we derive the conclusion when the data is very small? So many scientists from Europe that time and USA come up with small data analysis. Professor Tisakti, for example, with Taki method, and from industry, in German, we have student table. That is small data. At that time, we have problem with small data. But now, we do not have any problem with small data, but we have problem with big data. Not only big in terms of the volume, but other definition of big data is also multi-resources. So in this case, industry is part of multi-resource data. Move to statistical analysis. We cannot use conventional statistics, assuming the data is not too big, but now it's big. And also, the variety is not only single structure data, but unstructured data. The unstructured data from industry, from media, social media, from WhatsApp group, from many social media come into one or two problems with unstructured data. So how can we analyze that unstructured data using structured data? Usually I use with not big data problems, but the unstructured data is there now. So you are responsible in generating unstructured data. You give me problems now. Big data is big problem, but it's challenging. So the word now is not statistic and non-statistic, or industry or non-industry, or management or non-management. We are all the one now. So the student have to understand the beauty of the word, which is not single-minded only, but multi-resource resource as well as multi-persons and multi-sectors. Therefore, the student have to understand what is the moving of industrial problems, and not only in terms of analysis, but in terms of how to cope with that big data produced by industrial people. As now you maybe understand that we are in revolution, internet, what you call RE, industrial revolution 4.0, with this many technology now inside, and application, big data, data science, IoT, all inside of the problems. And then finally, the industrial revolution 4.0 is getting interesting. Me, for myself, as a statistician also, we are interested in analyzing that kind of problems. So then the theme of this conference is collaboration and resilience. Is very timely. From my opinion, collaboration and resilience, we need internal component in our brain, which is we have to open our mind. So we need the student open the mind, not single mind, not closed mind. We have to open the mind to be collaborate and resilience. And then not only open-minded, I think what we have to teach the student, we ask them to learn how to be an agile person. So to be resilient is not only sustainability, but agility. Agility is a term very important now, that we are getting flexible, not too rigid. Yeah, including in the term of big data, we have to face the flexibility of data. In industrial engineering as well as management, we need to open our mind and our agility. Therefore, we can create creativity and innovation. especially to optimize information technology. So I believe this is a very timely and important topic for you, for us, for all people. I am very happy to open this kind of international symposium on industrial engineering and management. So please continue the program as Ibu Nunung already mentioned before. And I'm very glad many people paper and call paper and as well as the keynote speaker. I hope you enjoy the conference and you contribute your thinking into the conference for the future industrial engineering and management, not only in Indonesia, but also in the world. So thank you, Professor Safino, coming here again to provide us some talk on your experience and everything related to industrial engineering and management. Thank you very much. Merci beaucoup. I forgot in Italy. Gracias. 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 Arigato gozaimasu. And sisi. And we'll open this ceremony by hoping to God, Allah Subhanahu wa Ta'ala, to save our event and to produce our creativity. Bismillahirrahmanirrahim. Thank you very much. Semoga semuanya berjalan lancar. Everything is going well. Assalamualaikum warahmatullahi wabarakatuh.
Asep Saifuddin. Ladies and gentlemen, honorable guests, we have now come to the welcome speech. Please welcome Chairman Board of Industrial Engineering Chapter, the Institute of Indonesian Engineers, BKTI PII, Insinyur Faisal Safa, ST MSc IPU, ASEAN Engineer.
Thank you, MC. Assalamualaikum warahmatullahi wabarakatuh. Good morning, distinguished guests, ladies and gentlemen. I see in the platform Rector of Al-Azhar, Prof. Asep, and I see the mycologist and former Minister of Transportation, Mr. Budi Suyitno. I see the senior Prof. Dadan from Trisakti and also Ibu Rina Fitriana and my partners in industrial engineering chapters, Wiza. And also the international partner Taiwan and Thailand. I see the 9 university networking in the ICM. It is a great pleasure that I welcome you all to this 14th International Seminar on Industrial Engineering and Management, and with topic collaboration and resilience towards sustainable industry. I agree with the Professor Asep. This is a timely for the country in the world to grow up after the pandemic. I see from the industrial side, and also I'm head of permanent in Kadin and BKTI, Industrial Chapter Engineering in PII, also as a team in the Kadin to grow the 3 sectors and 3 problems in Indonesia. The first, the vocational schools, further accelerating the vocational school, and also the local content sovereignty industry for the local content. And the third, and the theme of under president is how to enhance, how to accelerate the mineral downstream. And in June, all the mineral stop to export, if not the downstream the industry. And Indonesia is a nation of immense potential with abundant natural resource, a large and growing population, 230 million, and strategic location connecting the Asia-Pacific region. However, despite this advantage, Indonesia still classified as a developing country, facing various challenges, especially in industrial sector. Now, if you see the industrial sector, all the sectors in Indonesia are very low. Why you see the numbers of industrial growth below the economic growth? It's common sense in the business in the worldwide. Industrial growth is more 2 times and until 3 times the economic growth. The industrial sector has become the critical engine of economic growth for many nations, including Indonesia. It contributes significantly to gross domestic product, employment, and foreign exchange earnings. Now, if we see the R&D in Indonesia, only 0.09 from the GDP. Last month, APEC invited me to speak in the APEC forum, how to enhance the human resource and supply chain in the worldwide, because OECD stated and required if we go to industrial country, we must do 1.5 R&D from the GDP. However, we need to acknowledge that our industrial sector needs an overhaul if we want to catch up with other developing countries. Several initiatives and also the initiative from the ICM, make the international seminar, I appreciate to all, have been implemented to accelerate the growth of our country, including the developing country of specialized economic zone, improving infrastructure, increasing investment, and creating conducive business environment. We know this year is a political year, and also next year. This is a problem for the industry growth because the policy making not the have industrial side. However, there is still a long way to go. There are still challenges such as the skill gap, lack of innovation, and limited access to funding that require more attention. The government has realized the importance of industrial sector in promoting economic growth and has made considerable effort to improve the business environment. We did support this effort proactively and take advantage of the opportunity provided to us. Innovation and technology are critical. We cannot deny it, ensuring sustainable growth for our industry. Also, the all participants and our colleagues from the lectures in Indonesia and Taiwan and Thailand. The world is rapidly changing, and we need to keep up with the latest trends and enhancements. We must establish research and development center, enhance collaboration between industry and academia, and invest in education and training to produce a skilled up workforce. Benchmark for the Korea spending until 30% from the budget country for the research and development. Only research and development, no infrastructure for the research and development. Only the human, 30% from the budget country. This seminar provides an opportunity for experts, policymakers, and stakeholders to share their knowledge and insight on how we can accelerate the growth of our industry toward becoming an industrial country. We trust and we believe industrial country is a must 1.5 from the GDP. Yeah. And now the Korea 4.5 from the GDP, from their GDP. We must to accelerate for development countries to come up with the R&D. We hope that from this event in international seminar, we can identify practical solutions, not just the paper. Because I'm in the side, we need recommendation from your all lectures. To the challenge facing our industry and come up with the actionable recommendation. In conclusion, I believe that Indonesia and also Taiwan, Thailand, and other Asia countries, industrial sector has enormous potential for growth. And by working together, we can make it happen. Let's share this opportunity and set the stage to transform our industry toward achieving our goal of becoming a developed and industrial country. Thank you again. And last but not least, we have the same background, industrial engineering, now timely. Yeah, agree with the Professor Asep. This is a timely. Yeah, not the time. And last year, me and Portugal ITB make the solution and hypothesis maybe only 7 years future. Indonesia exit to middle income trap. 2030, if don't exit the middle income trap, 2030 in the below the middle income trap, as long as future Indonesia still the below the middle income trap. Yeah, not 2045, not 2030. Now, basis for the exit the middle income trap R&D and sovereignty industry. Thank you, and we wish you fruitful deliberation during the seminar. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. Big applause for Mr. Faisal Safa. Thank you very much, Mr. Faisal Safa. Ladies and gentlemen, for the next agenda, we will continue from CYCU Taiwan side with MC Riana. Please, Riana.
Thank you, Yogi. Ladies and gentlemen, we would like to give our highest appreciation and honor to our international partner from Taiwan, which is the host university for the hybrid conference of the 14th ECM 2023, Zhongyuan Christian University. We would like to invite and welcome the Dean of Electrical Engineering and Computer Science College, Professor Cheng Yuan Chan, to come forward, and which will be followed directly by Professor Yung Sang Jo as the Chair of Department ISE CYCU. Thank you.
Ladies and gentlemen, good morning. And Lin Dong, Chen Jiao, welcome to this hybrid conference. I believe this conference may be the first conference in campus after the COVID pandemic. I really hope this kind of collaboration can improve future collaboration through fruitful discussion. And I hope all the delegations from Indonesia, Thailand, and everywhere in the world can enjoy this conference. Thank you very much.
Thank you for Professor Chan, and we welcome Professor Yung Sang Jo to give the welcoming speech.
I have to read my draft. Sorry, but I'll control. I make my speech shorter. I mean, schedule on time. Okay. So to Dr. Yunang, Chair of 14th of ECM 2023, to respected keynote speakers, and to our distinguished guests, ladies and gentlemen, a very warm welcome. I feel extremely glad to welcome everyone to this much awaited conference, as it marks the 14th meeting, and it gives me immense pleasure to be standing in front of you all, amongst the most esteemed personalities who have won accolades in their respective field. Before we kickstart the conference, I would like to express my gratitude towards to you all who sincerely contribute to this event in order to make it a success. This wouldn't have been possible without the support of each and everyone present here. I'm highly obliged to the research scholar who have made it to the conference, and it will be presenting their paper on collaboration and the resilience towards sustainable industry. This paper would ultimately enlighten all of us present here. Okay. So, to the end, the synergy between collaborative network and the sustainable manufacturing need to be further explored. Heartiest congratulations to all the presenters, as without your support, this conference wouldn't have provided to be beneficial to this extent. So hope you have a great conference today. Thank you. Thank you so much.
Thank you for Professor Zhou and also Professor Chang for the welcoming speech from Taiwan. And now back to Yogi.
Thank you, Rihanna from Taiwan. Ladies and gentlemen, next agenda is the partnership ceremony. We would like to invite university representatives and International Partnership Committee to join, and please come forward to the stage together in Jakarta side and CYSU Taiwan side. We invite you to come to stage. Dr. Rina Fitriana from Trisakti University. Dr. Sarif Hidayat from University Al-Azhar, Indonesia. Dr. Novi Erni from Esa Unggul University. Dr. Wahyu Katon from Universitas Pasundan. Dr. Lamto Widodo from Tarumanagara University. And Dr. Dino Rimanto from Pancasila University. Please, we invite you to come to stage. Okay, Dr. Nurli, representative from Pancasila University, please come forward. And now, please, Rihanna from CYSU Taiwan side.
Thank you, Yogi. Ladies and gentlemen, we would like to give our highest appreciation and honor to our university committee under ISIAM who are now present in Taiwan. First of all, I would like to invite Dr. Vivi Triyanti from Atmajaya Catholic University of Indonesia. Secondly, I would like to invite Dr. Ipov Kumala Sriwana from Telkom University, Indonesia. There is also Dr. Rami Maulida from Trisakti University, who is also on site here. I would like to invite Dr. Yung San Cho from Chung Yuen Christian University. And finally, I would like to invite the beautiful Dr. Naraporn Pauprasar from Katsasart University, Thailand. We would like to invite the representatives, and as a symbol of unity and excellence, we invite the representatives to give the best thumbs up and take a picture together. By the code 1 to 3, we would like to have the thumbs up together. Okay. And this is the session to take the picture. Thank you. And we welcome our honorable guest to sit.
Thank you.
Thank you very much. Back to you, Yogi.
Okay, thank you, Rihanna. Okay, please be seated. Thank you very much. Ladies and gentlemen, and now let us, Ladies and gentlemen, honorable guests, please welcome our first keynote speaker, Professor Matteo Savino, Professor of Industrial Operation and Industrial Management, University of Sannio, Italy, as the first keynote speaker. And also we kindly invite Dr. Sarif Hidayat to be the moderator of this session. Dr. Syarif Hidayat, lecturer in Industrial Engineering, Department University Al-Azhar, Indonesia. In Education, PhD in Supply Chain Management, Bogor University of Agriculture. Research area, Supply Chain Management, Modeling, and Enterprise Resource Planning. Okay, please, Dr. Hidayat, to lead this session. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera for all of us. Om Swastiastu. Good morning, everybody. It's an honor for me to sit here again, moderator, after several years of silence since 2018 in Makassar. At this happy morning, I am very delighted to present to you, all audience, to the seminar, the first keynote speaker who comes far away from Benevento, Italy, Professor Matteo Mario Savino. First of all, please allow me to read a very short CV of the professor. Matteo Mario Savino is a full professor of Industrial Engine Operations and Industrial Management at the University of Sannio, in the city of Benevento, Campania, Italy. He received his PhD in industrial plants in 1999 at the University Federico II of Naples, Department of Design and Industrial Engineering. Among his research interests, there are project management, risk management, assessment, quality aspects related to industrial production. He has managed several national and European Union-funded research and educational projects. Since 2008, he has been a delegate of the Rector for Quality Assurance and is the president of the University Quality Center. Professor Savino is also quality assessor for Italian Ministry of University and Research. He is the author of more than 90 scientific publications and participates in international journals and international peer review proceedings. He was born in 1967, only 66 years old, still going stronger, hopefully. Professor Matteo is married and with one daughter. So his spouse, Mrs. Rosa, is now here together with us as well. Professor Matteo pastime is traveling to enjoy panoramic natural sceneries, especially in the high mountainous areas. Yesterday, we spent full day touring the Gunung Mas plantation and the surroundings. Today, Professor Matteo will deliver his keynote speech entitled Machine Learning to Manage Preventive Maintenance Based on Product Quality Data, a Success Case. The professor, it's a great honor for us to have you as the first keynote speaker. We are extremely grateful to you for accepting our invitation and coming all the way far away from Benvenuto, Italy, personally, to deliver your speech live. You'll have the audience for 35 minutes. Then after that, we will entrain the audience with perhaps only one Q&A session for maximum maybe 5 minutes only. We understand that you have to catch up your flight back to Singapore and then all the way to Italy. The audience, here is Professor Matteo Savino. It's up to you. I have to stay there. Okay, I'll see this slide.
Good morning to all. Thank you again for inviting me for this long-lasting cooperation and friendship with Al-Azhar, Indonesia, who has been one of my distinguished partners in one of the biggest projects that has been conducted between Europe and Asia, namely LEADER, with which more than 200 of students, doctorals and postdoc, moved to Europe, and among them, several distinguished doctorals and postdoc from Al-Azhar, Indonesia, have been to Europe, and particularly to my university, and made a very great and good job, and made exceptional and very hard work research, producing results for their promotions and career once coming back here. So we have been very happy to have helped and to have cooperated with this university. After this, first and foremost, let me give a warm thanks. Please, next slide. Next slide, please. Please let me give my warm thank to Professor Sharif Hidayat. Please keep that slides and pay attention to what I'm saying. Change the slides only when I say you. So my really warm thanks to Professor and my friend Sharif Hidayat, who has been very kind with us and took care of us in taking us in very wonderful places in surrounding Jakarta, in the hills, tea plantation, getting very good quality tea, for which I have that is my passion. And another very warm thank is for Hidayat Yoranta Sasairila, who has been also, as well as Ipov and Nunung postdoc to me, to us, at the Department of Science and Technologies. And now and then I came to know that he became dean here. So I am very happy to have been here and to have this kind of experience. Next slide, please. So let's go on let's move on the scientific part of this speech. I shall present you a specific case study of industrial management regarding preventive maintenance based on quality data. So I heard from your distinguished director about Industry 4.0 data analytics and problems regarding this. Well, this is a small contribution to this kind of topic that is of great attention for industry worldwide, and of course here in these countries in which industrial production is a very key point regarding the advancement and the possibility to have goods and industrial products in Europe as well. This is the agenda. We shall see the context in which this has been conducted. Then we will see the process. I will relate you the critical point of the process, then how we fronted the problem of preventive maintenance, and of course the managerial implications that are upward regarding the finding of this work and the possible limitation, of course, of this work. Next slide, please. This is the industrial context in which we moved. It's a company which is a supplier of ABB company, the big company regarding electricity conversion and transportation. This is the product that we dealt within our process. Then let's go to next slide, please. And this is the process that we fronted in terms of maintenance and critical operation. Among this is, as you may see, a flow line production process for which it is critical maintenance because the stuck of a workstation may stuck the entire process. And the most critical workstation, the most critical process that we detected as a bottleneck of the whole production process is the process number 3, in which a vacuum pump is putting insulator within a case. Next slide, please. Let's go. Okay. Continue, please. Okay. Now, please click on the black part of the screen. Go down, please. On the black part at your left back. Find the button. Something happens. Okay, this is a video of the process that is critical for the entire production, and you may see the vacuum pump, which is making this kind of plastic component within a case, and it is the insulator part of the whole product, which is very critical, because if the insulation is not perfect, the current and the voltage transmitted and given to the component is not compliant with the specification of the design process. Hence, it may be discarded. And what happens in this case? That this can be a good signal of a potential malfunction of that process. The possible defectiveness are those that you see here: bubbles, not compliant complete insulation, and so on. So what was the problem? The problem was to make the correct preventive maintenance to the machine based just on the non-compliant data. Why just those data? Because those data were the most available one that we had to see how the machine was working in the past. As you may see, preventive maintenance, machine learning, is based on learning by the past data. If you have enough data, you have a reliability data set, which your rector named big data, that can be analyzed and the machine can be managed according to the specification of working, so making it the most active as it can. Okay, let's go to the next slide, please. Okay. The critical components, as we said, is the third operation. Okay, the third operation is the most critical one, and is a vacuum mixer machine. It is made of 3 phases: the loading one, the degassing phase, in which the humidity is eliminated, the residual one, and the dosing phase, in which the vacuum chamber is applying the rays into the transformer. One of the data of this phase is the vacuum pressure within the tanks. And it is significant to the success of the dosing phase, because if the pressure is not enough, then the bubbles and the defectiveness and the non-compliance will appear in the product, and the product should be discarded. Okay, let's go next one. Okay, vacuum pump has been detected within the process number 3 as the critical machine of this process. It has to say the machine that had to be monitored and for which the data had to be got. Please, go on. What was done before? The preventive maintenance was scheduled based on thermographic inspection. This is a thermographic inspection of the vacuum pump, which is just behind. It's the photo behind this one, okay? And in regard to this, you may see the green area is the part of the area in which the temperature is lower. When this area begins smaller and smaller, it is a signal of the increasing of the temperature of the vacuum pump. And it would be a signal to make preventive maintenance. But this is just empirical, and it is just left to the experience of the maintenance engineer, who may be also a young engineer. It was not enough, because very often the machine had failures and had to be stacking the entire line. Let's go to the next slide, please. Hence, we kept the thermographic inspection as a main driver, just to have a comparison, and began to get the input variables of the process. We detected 8 variables: the tank pressure, the hardener tank pressure, and the degassing tank pressure, along with the vacuum chamber that we described before, or il millibar unit of measure, and then the temperature, which was the only one factor monitored before. So we detected that the temperature of both 4 pumps, of course, in degrees Celsius. Please, next slide. Okay. How we organize the process variables. So I am delighted that your rector is here with a statistic. So we organized it in a matrix, in an input matrix, made of 8 multiplied 150 rows, okay? While the output was a particular indicator of the quality performance of the machine. So see what we did. We took something which was apparently not related to the maintenance of the machine, the quality index of the machine, and we tried to find the link between this quality index and the maintenance status of this machine. The quality index is named the first pass yield of the machine. So it is a yield. It was an indicator imposed by the customer. So the customer said, if there is a first pass yield less than 90%, the process is okay. If the first pass yield is between 90% and 95%, the process has to be monitored. If the first pass yield is bigger than 95%, the process must be stopped, and the components should be revised. So these are the process variables. This is the input. So the challenge was to have an input to those process variables with those data that you saw in the previous slide, and to have an output, an array of the first pass yields of the machine, okay? And between this input and output, we had to find the correlation to define the preventive maintenance. So the mean time between maintenance of the machine. Let's go on, please. Okay. This is the information system that we set up regarding the analysis, the machine learning analysis of this portion of the study. This is related to the 4 vacuum pumps. See here, the data of the pressure are got by the artificial neural network. After the processing of the artificial neural network, they have been processed by a fuzzy inference engine. This to translate a numeric variable to a linguistic variable, and the contrary. So we may say that a high first pass yield may generate a high necessity of maintenance. And what has to be the output of the system? The corrective action taken to the product, not to the machine, to the product, and the preventive maintenance inspection of the same machine, avoiding to stop the machine. Let's go on, please. Okay. The rule base, we set up something like, my lab set up something like 350 a base of 350 rules, with which a defalsification interface made the judgment action high, medium, level regarding the first pass yield, suggesting the action of no action, checking the pump setup, or check the engine setup, which this last action may impose to stop the machine. Let's go on, please. Okay. So just a small example of the working of the model. I'm just descending this stair and come here to show a bit better from you, even if the friends from Taiwan may not see me, but it's better that they see this.
Professor Matteo.
Yes.
Excuse me, you have only 10 minutes left. Only
Okay.
10 minutes left.
Okay.
Yeah.
Just going to finish. Thank you, Sharif. So the parameters is in the input parameters, the pressure, see here in millibar, the temperature, see here in Celsius, in grades Celsius degrees. The artificial neural network, after the learning process, estimated the first pass yield of equal to 3, with the input indexes of 0.333 always, and 0.39 then. The Precious VP4 is low, see here, 10 millibar. The estimated FPY is 2, and see this index is continuing to increase. Again, let's go to the vacuum pump number 4, going to low the temperature and going to higher the temperature, 61 degrees Celsius, very big eye. What the estimated FPY was 1, machine stuck completely. And the fuzzy inference engine resulted in 0.83 with the last value. So this, we learned from this that the machine learning phase was well conducted, and passed to the second and went to the second phase. Let's go on, please. Let's go, please. No, let's go. Yes. Okay. So the model, after this learning phase made in the lab, we went to the file, we applied for 6 months on the line. And the setup errors predicted from 32 originated by the past observation, generated a possible failure of 14, so 14 failure. The real one was 31. So what we detected by the system was exactly what, more or less, what happened. See the possible failure. The real 13 predicted 14, not one, just one not predicted, which is maybe a good result regarding this. Let's go on the next one, please. Let's go on the most interesting results coming after the 6 months of operation, plus 2 months of observation, additional observation. Then the system was left in operation because it was judged as reliable by the firm. So the operating time of the machine before the preventive maintenance system was 1,248. After was increased more or less of less than 10%. But the number of maintenance events decreased from 32 to 27, which is a satisfactory number. And above all, the best result was regarding the mean time between maintenance and the mean time to repair. This was increased of more or less 20%. These had a strong decrease of mean time to repair because we had no failures at all. All the failures were predicted by the system. The FPY, the first pass yield, increased not so much because it was okay. You know why? Because they detected through the thermographic inspection and stopped the machine. So the defectiveness of the machine was already low, but the maintenance operation were a lot, stocking the machine for a lot of time. So the quality index was okay, but the productivity and the productive capacity, the effective production capacity of the machine was too low for having to make the machine profitability. So this is not a big increase, but the main task were to decrease, to improve maintenance, the maintenance performance of the machine. This kind of graph is the mean time between maintenance compared to the weeks of operation. See, it's more or less stable. And this is the graph that you may see of the FPY index that we already commented and made and described it before. Please, next one. Okay. Then we made the cost analysis. Go on, please, fast again. So after we made an analysis of costs, if we have statistical and economic and management, business management scientists here, we added this study in order to ensure to the firm the real profitability of the system, and see what we had to include here. For this kind of cost, these are familiar for you: downtown cost, maintenance cost, and scraps cost. For us as industrial engineering, they are very familiar costs, they familiar analysis, but they imposed us, they requested us to include the model implementation cost, because inside the firm, when we had come out after the system setup, they had to form people, they had to buy other machines, other computers, and they had to continue maintain the system. So we need to add this model implementation cost. Here you may say the missed productivity hourly cost and the mean cost of maintenance intervention. See here, before preventive maintenance system and after preventive maintenance system. The best result is the cost regarding the scraps cost, which decreased of 63%, and the maintenance cost, see here, the cost M, here, it's here, which decreased of 15.7%, which were excellent results. This was one of the best results and one of the best project conducted within industry inside Industry 4.0 research stream that we conducted with them. Okay, I think that we may finish. Let's go. Okay. We made also a verification of another process of the system, a turning process, same procedure, same kind of data, first partial and so on, but the machine was different, just to see if the model was robust enough and reliable enough to be applied to different industrial process. Let's go on, please. Okay. So which are the conclusion? The conclusion, the scientific conclusion is that the average between the two analyses made a decrease of the, made an improvement of the mean time between maintenance from 37.8 hours to 48.6 hours. The FPY was increased from 96% to 98%, with an overall cost decreased of 37%. Which are the managerial implications? This is one of the best results that we got in terms of this. Please, next slides. Managerial implication is that supporting production manager and maintenance manager in planning and maintenance activity may be also possible with quality data that usually maintenance manager don't have. Production manager may have quality data. Usually maintenance manager have no access to quality manager and often disregard to analyze quality data and to find a link between quality data and the possibility to improve the maintenance indicators, the maintenance performance of the machine. So this was the first. And a single framework of maintenance may allow a concurrent control of costs of maintenance and cost of quality. So you got two shots to target with just one activity, which is very well welcomed by this firm, has been, and I guess the most part of firms that we are dealing with, proposing and continuing to apply this kind of system. Now we are applying this system to the railway maintenance operations regarding the components of energy transmission, of current transmission on the line of the trains, high-speed trains. There are indeed, like every activity, no matter as well conducted, there are some limitations. So correlation between machine status and quality rate require always an in-depth knowledge of the manufacturing process. So we claim for the knowledge of manufacturing engineer, production engineers who had to make this kind of experience and knowledge towards the quality engineer, together with the quality engineer and to the maintenance engineer. Joining together this kind of experience may make a very key and very important and key steering towards an integrated management of production process and maintenance process. So in my understanding, this is a main limitation, but I I invite you to read it as a main opportunity to join the knowledge of different engineers and also to get the knowledge of statistics engineer, which may improve the statistical data, the statistical analysis of the data and their reliability. The implementation of the fuzzy inference engine as the second limitation, the second main, there may be others, but these are the main two. The implementation of the fuzzy inference engine would require the gain structured analysis regarding the shape of input function. So defining the exact shape of the input function of the fuzzy inference engine may affect the reliability of the machine learning and may delay also the learning process of the machine learning. We selected some shape of the fuzzy membership function, which was trapezoidal, but a part of the research of extending this research stream may be also directed towards the correlation of different different membership function towards different results of the machine learning, making a better tuning of the machine learning as regards to the shape of the membership function, which may affect, in better, only worse occurs, the reliability of the machine learning system and may delay also the process.
You have only
Thank you.
2 minutes. 2 minutes. Oh, it's done.
I thank you for listening this keynote speech. Again, thanks to Syarif Hidayat and to the organized committee of the entire ISIEM conference for inviting me. My respects and greetings to the rector of Al-Azhar Indonesia. Thank you to all.
Thank you, Professor, for the inspiring as well as intriguing speech. So, the audience, I'd like to invite you to put forward your questions. So, we only have 5 or 6 minutes for the Q&A sessions. So, I'd like to invite you, perhaps can invite only, Pak Rektor sendiri. Okay. And then Pak Rektor, one, and then the second one.
Hello, Dr. Sharif, there is one question from the Taiwan on-site. Is it possible?
Okay. One question from Pak Rektor, one question from Taiwan. So please, Pak Rektor, your question, please.
Thank you very much, Professor Safino. Matteo, and it is very important, interesting topic, although I'm not that good in engineering. So my question is, based on my experience when I use machine learning on statistical data analysis, usually we use that machine learning based on statistical model with usually using a previous assumption that the input variables and the output variables may have some error. In my case, when I use for health and also economic, we assume the model is, we have some what we call white noise. In this case, do you have also some white noise to use machine learning in engineering? Thank you.
Thank you for your questions. It's really interesting, and it gives me the chance to better point out the context of the model and how we move it within the model. Basically, within industrial operations, and specifically for certain industrial operations, the problem of the noise of the system is not so important. This is for two reasons. Because first of all, we have indeed big data, but it's not so much big data. The amount of the data is not so big as regards, for example, to sanitary sector, to economic sector, financial sector. Okay. First is this. But the main issue that we do not matter about the noise of the system is regarding that the industrial process that I had the possibility to show you, basically the first one, but you may also see from the slides, because this work has not been published yet. So also from the slides, you may see the second one, turning process, was a mature process, a very mature process, for which it was very well known the input data, and the output data was the first pass yield, which was imposed, so it was deterministic, by the customer. So the noise in this case was not considered because did not affected in maximum part, maximum consideration, all the analysis. I just add some issues regarding to this speech, because we dealt with noise issues, and Ipov, who is now in, and my greetings are also to Ipov, who is now in Taiwan, and dealt with those when she has been to me with their postdoc activities, with their scholarship to us. We dealt with this for data regarding the perception of the quality of the product coming from the market. We made a very interesting doctoral thesis from Chinese data. The doctoral was a Chinese, Chen Qiang, from Guangzhou University. Ipov helped him and worked also with him along with the Pakistani postdoc. And from that data, we had to consider the noise issue. How we dealt with this problem? With the filtering function, in which a fuzzy inference engine detected the most distance data from a mean, and as regard the mean standard deviation, and we took off this kind of data, judging them, considering them as noising data that may affect the good result of the system. Hence, for this particular research, we didn't consider noise. We consider noise for market data, quality data coming from the market, from big markets like China, for example. And our way of filtering noises is more or less standard deviation, and cutting it at 3 sigma, 2 sigma. For electronic sector, we cut the noise at 5 sigma, going towards and towards nearer to the 6 sigma, which was the Taguchi philosophy of zero defect, but not reaching that because the effort would be bigger and bigger to set it.
Excuse me, I have to allow one question from Taiwan. Okay, so please, the Taiwan part, please, we give you one chance of quick questions. Sorry, it's close to 10:45 already. Okay, Ibu Rina atau siapa ya yang di sana?
Dr. Sharif, can we still have one question from Taiwan?
Yes, one question from Taiwan, please.
Professor Sharif.
Yeah, due to the time limitation, let me just ask a very quick question. First of all, I think we are very interested about Dr. Savino's work. I think if you can give us publication information, then we may read your publication more thoroughly and to understand your work. And the second part is like when I look at your slide, I saw there's a mean time to repair. I don't know why the mean time repair just decreased. Would you say more like when we try to mean time between failure I cannot see the relationship between the mean time between failure and the mean time to repair. Okay, thank you.
Thank you, Professor Xia.
Thank you for your question, for having appreciated this piece of work. The mean time to repair had a strong decrease in regard to the fact that the matter was that just one failure maintenance was made, had to be made during the 6 months of operation of the system and the 2 months after of follow-up. And making only maintenance, preventive maintenance operation, there were a strong decreasing of the detection time because we had no real failure. Making preventive maintenance, we knew what they had to do and to change in terms of spares. So they didn't have detection time of the failure because the maintenance operation was known, and above all, they had no mean time. They had mostly zero mean time to wait for spares, which you may understand, you may indeed know, that may contribute to increase the mean time to repair. So there's the strong decrease of these two components of the mean time to repair allowed these results of decreasing mean time to repair. Then going towards the operation of the machine during the 2 months of additional observation and follow-up, the operators were very well trained in using the system, and they already knew when the FPY went down, what kind of maintenance operation had to do, and they continued and contributed to decrease the mean time to repair, not only in terms of diagnosis time and detection time and mean time to wait for space, but also for the skill that they acquired in making the preventive maintenance.
Thank you for the answer. I'm sorry. In the rest of the time, I have to stop the Q&A session because already 10 minutes to 10, and Professor has to catch a flight to Singapore. So let us give him a round of applause for Professor Mateo. Shall I give it back to the...
Yes, I would kindly invite the rector of the university. This is our historical site, silver plate. Yes, this is the logo, which is this logo is around this logo has 600 years old, and it was the founding of the city and of the school that was in the city, that then became the university. Okay, so we wish to continue this fruitful cooperation and to have other projects with Al Azhar Indonesia. We shall think about Al Azhar Indonesia for Asian project that we could submit towards European Commission.
Sure. Thank you very much. Thank you very much. I will keep in touch. And
absolutely, yes. I have your business card.
Thank you very much. Very nice. Thank you very much. Thank you. It's a very old university, 600 years old. Yeah.
Yes.
Not in Al Azhar is only 23 years old. So we are all grandson.
We try to keep in touch.
But the most important is always young. Okay?
Not completely true, but by the way.
Thank you very much.
Thank you.
Yeah, thank you, Professor Matteo and Dr. Sharif. Please still on the stage. We will give an appreciation from the chair of 14th ECM committee. Please come to the stage, Dr. Nunung Nur Hasana. Okay, thank you. Please big applause for keynote speaker and moderator. We would like to inform you for all participants at Grandika Iskandarsyah Hotel, Jakarta location, please take meal, tea, or coffee for the coffee break session and be brought into the room, and the keynote session will continue. Thank you.
and all of my department, industrial and the system teachers, because now I'm the study in CYCU, the PhD student. So thanks to the teacher visit here. And today, before I speak, I will put a video for everyone to watch.
Motion, mobility, the power to move faster, further, better. The ability to make every small part interact and perform in order to get to a desired destination, in order to reach a goal. You may think that we are talking about our motors, our AGVs and autonomous mobile robots, or our mobility scooters, and to a certain extent we are. But in reality, this aspiration to move forwards and upwards, this irrepressible desire to move faster, further, better, represents us, each and every one of us, the people at Motion Tech Motors. We combine our expertise with enthusiasm and positivity to be the leaders in our field and to bring a ray of sunshine to our industry. Motion Tech Motors. Passion for motion.
Okay, thanks everybody watch. Good morning, everybody. My English is not very good, so I only use the simple English, simple words to introduce my company. And the topic is industrial smart manufacture and sustainable development strategy. This case, a case study at the Motion Tech Motor. About the Motion Tech founded from the 2002 to now, about 20 years. If you know, in Taiwan 2000, the economic is decreased because the political party is rotation. So my MBA, the advisor, the professor say, if you to build the business, you will fail. But I do not believe. So I trust I can to control and I can progress in near the future. So I focus the power wheelchair and the scooter in this industrial. And from the beginning, our capital is very few, about 130,000 US dollars. And the 20 years, my capital is more than 40 times. Now, my capital is 8.3 million. And I sold my product for all of the world. The marketing share more than 40%. So in Taiwan or in Indonesia, Italy, and Thailand, many countries use my transmission, the motor, gearbox motor in the power wheelchair and the scooter. And now I sold to the product more than 50 countries. and per year we have more than the 15% to increase. How to do? I think we must have the strategy. So in the next page, I will introduce. I plan for 10 years planning. Every planning, we must to have the strategy and the action. Later, I will show to everybody. So motion tech, I simple to call MTM. MTM is a remarkable manufacturer of the power transmission industry, driven by our relentless system and expertise. We have been present forward a number of years, working closely with our clients. Because if you to be let the customer in the center, everything you must to meet the customer demand. If you can satisfy the customer demand, I think you can get much money, many the order. So we bring our energy and the resourcefulness to every partnership. MTM, M2 empower, equip, and energize every single client with the right motor solution and plenty of positivity. So I'm the IE student, but I design some formula for every power scooter the customer, how to calculate about the speed, the climb, slope, anything, so they can easy to calculate how many the power and how many the gear ratio you want. Can to reduce the R&D the timing. So next, I will to introduce and share our vision and the mission. We have the two parts. One is the business, the vision and the mission. Second is the brand, the vision and the mission. Now, we can to show the brand vision. We will to be the energy source or the power transmission industry. How to be the energy source? I think it's very important because we must do thinking about the customer, employee, supplier, and the user. I think, okay. So everything, I want to think in, how about characteristic for every customer? Everything you must do thinking, characteristic thinking. So how to be the energy source? We must do trust. You must trust your customer. You must trust your employee. And you must trust your supplier and the user. And the supply chain, we must to forecast for our supply chain. We know before 2 years ago and the last year, all of the world, the supply chain had problem, but I think motion tech is no problem because we have a long-term schedule and a long-term forecast for our customer and our supply. So how to be the general source is very important to thinking long-term cooperator relationship. So how to with your customer co-work, co-design, and to face the question and the solution is very important. I think the document is wrong. Yeah. And then this is the old one. Yeah. And the other I want to share, not the PPT, is our operating the strategy. How to upgrade your product. My business, the management for the region. My mission is to be the excellent products and reliable the partner. How to be the excellent product? So you must like the IE the many the session. We how to use a lean production. We how to use the Six Sigma. We how to use any TQM. So I think it's very important to use the IE the skill to your company, so you can to offer the excellent product for your customer, and your customer will trust you very well. And my business, the vision is to be a group with 10 billion per year. How to do? I think that is a very important plan or the long-term strategy. Later, I will show about in the near future, our company have the many the products. Which from the beginning, we only produce the motor and the gearbox, the components to the system, to the product. I will show to everyone. My brand the mission is to draw closer. We must serve very close with your customer, with your user. Like last week, I go to Korea. I just come back Saturday night about 11 o'clock. So I prepare the presentation. So we want to know, like Korea is the kiddie area. So even the motor and the gearbox ratio were different. If I only to know the power, not too concerned about the area, like mountain area or the something, some like the hilly area, your product maybe will your problem. So you want to thinking about the every customer use your product in anywhere. So we must do closer with your customer. Maybe you must do thinking about your user. Sometimes the user is for the handicap, and sometimes it's for the old man. So you must thinking use what's the product for your customer, for your user. And then we will must to move first, because speed is competitiveness. Okay, so you will change the right PPT. Okay, so we must to the move first, because speed is a competitiveness. It's a competitive strength. So how to quicker to salute every customer, user, supplier, employee is very important for the near future. And then it's the energy. Our brand feeling. You must to let everyone, customer or the user, to understand your feeling. Now, like the energy, you must match your power, because we must control our core of the technology. What is our core competitive? It's very important. Okay. But I cannot move. Okay. Okay. So The energy you will find your the human resource, your R&D, your the QA service, sales department. Every department will to really the energy to solve every the question. And then motion, not only motion tech. How to motion you are the passion. How to motion about your any action is very important for your brand feeling. Then our brand next page, our the brand value. I think not this page. My brand value is the cooperation, because I talk to everybody is altruistic thinking is our attitude. Because if you anything you think altruistic, you can do everything as well. You must do thinking with your customer, your user. Like I go to Korea, I will to a new office in Korea. I have an agent in the Korea. He sold some the motor for the LG the sorting machine, but he want to control only one the agent. I said no. But it's per year, the customer the order is more and more. So I'm thinking how to cooperate and to thinking for our customer. So we to build the new office and together. The customer share, stock share about 51%, but the name is MTM Korea. So customer is very happy. He can to expand the marketing. So anything I want to thinking about altruistic thinking is very important. And then we must to the expertise. We must be professional to manufacture and the design and to know your product. So expertise is very important. But I think next very important is positivity. Everything is positivity is very important. You can sometimes if you have any the question you are thinking and said, but if you have the positivity, I think you can easy to control and solve everything. So this is our brand mission, value, and the feeling. And then next page. Then I will to introduce about the 4 decades plan. Before I will build my company, I'm thinking the 40 years. So I will retire about 76. I will retire. So first, I can do thinking first 10 years. I want to build our core technology. So we want to think in our product. So 10 years, I mean, name is the product of motion tech. So I will serialization of product and the production service. And I'm thinking if at the beginning 10 years, every 10 years, I will build a new factory. This meaning we have a new department for the beginning. So second 10 years, my name is the management of motion tech. So the 10 years, I have the some the service the data and the data system. Like we use the ERP and we use the Six Sigma and any data like the big data to analysis. So how to know the result about the 10 years? Later I will show to you. And then this year I go to the next stage, like the innovative the technology of motion tech. So I will to the touch about the AI or the intelligent system and the intelligent the technology. So later I will show you the next product is what and how to integration. So this year I will to finish the second factory. And the last four years, synergy of motion tech. I want to vertical the integration and expand the global production. In the near future, I think I will to build the enterprise group building. Because every 10 years, I have my target and I want to do what's the product. I will follow the career and follow the action. So next page. Next page is about the 20 years of history. You can to see from the 2002 and foundation. And this 10 years, we produce many products from the brushless motor, gearbox, anything. And then the second 10 years, you can wait to got the Golden Trust Award, the National Brand Design Award, and the National Award of Outstanding SMEs. Anything. We have many awards this year. And the last year, we also got the Happy Business Award. And from this year, I think we must to overseas agents expand. So from the February to now, I go to the 3 countries. First, the February 1, I go to the Singapore, and February 23, I go to the Malaysia, and last week I go to Korea. So we must to expand our overseas. And April, I will go to the German, and then I will go to America and go to the China, anything. So I think we have the schedule is follow our 10 years the planning. So we have the planning, we have the target, and we will to check how about our performance. Next page. So I think the next page is the same as before. So we direct to the next page. We introduce our product. So this is a simple product. In the upper is the motor. Only the motor is only the components. And then we use the components to combine the other components like to the gearbox motor. And the below is a driver and the vehicle and the other product. Next. This application, I think mobility, the scooter, I think in your country, you can to see many mobility scooter. like and the marketing share in Korea is more than 55%. In the Thailand, I think our marketing share is more than 90%. In Taiwan, also 90%. I say another scooter, I only sold gearbox motor, not the full scooter. So we also application for the scissor lift and the tread vehicle. I found I sold the gearbox motor to the controller system, and then I will to agent to be their agent and sell to the overseas from our sales the channel. So sometimes you use our product, but you don't know. Like when you go to Taipei, the high-speed train, the open the door is my motto. If you go to the like you want to the airport, your high-speed pass, the motto also use our motto. And in the hospital, the food truck also use our motto. So many the players use motto, but you want to know what is the situation and what's the function for your product and the customer product. Next page. And this is our new one for the AGV AMR. And last night I go to the restaurant. The AMR is moving. The base is use motion tech motor. And the second one, the shorter conveyor is I talk to you is a AGV, is a LG for the MD, the Korea the customer. Okay, next page. Yes, I'm simple to explain about the AGV the base. I think last night we go to the restaurant. You can to see the base is similar this. It's a similar this. Yeah, I from the beginning the transmission and the integration about the sensor and the I/O box module and the battery BMS. We can do integration together. So now we will first to the OEM for our customer. Next stage is the ODM for customer. And then we'll design and the OBM for our customer. I think this stages and step by step to the marketing. Next page. So we also have the government invest NTM to research a car. In Taiwan, no any the company to produce the small electrical street sweeper. So from this year, we have the Taiwan #1 set the small electrical. So I integration from the clean AMR to my small electrical street sweeper. So we took integration to the clean machine, the business map, like this. So from this year, we are beginning to sell to all of the world. Next page. So motion tech corporation, corporate social responsibility, I think is a very important is for the ESG, because you know in the I think from the 2000, 2026, maybe the Europe will to the tax the carbon tax field. Our teacher Lao Xin tell me, yeah, we must to notice the carbon problem. So I want to use the ESG for our company. We also founded the welfare charity Sunshine Assistive Technology. This is for the language disability the children, cerebral palsy children, and the retarded children. And the other many have some heart the children have problem. So I invest some money and help them to do it. So next page. So the final, I think we found the 16 SDGs in my company. So I must to solving the ESG the DNA in my company. So we want to tell the R&D how to reduce the material, the manufacturing, and we must training our employee how to notice the ESG. So ESG in my company is slowly, and we have target and action to do it. I think in the near future, I will finish this. And then I have passed the ISO 14067 and the carbon footprint. And the next this year, we will pass the ISO 14064 slowly to finish. So I think in the near future, we must together to push the ESG for every company and everyone. So we passion for motion. Thank you very much.
On behalf of the organizers and attendees of this event, I would like to formally express our heartfelt appreciation for the exceptional keynote speech delivered by you on the topic of industrial smart manufacturing and sustainable development strategy. Your insights and expertise in this field were truly remarkable and have left a significant impact on all of us. For our third keynote speaker, Professor Ping Sun Chen is a highly accomplished faculty member in the Department of Industrial and Systems Engineering at Chungnyan Christian University, Taiwan. He holds a PhD in Industrial and Systems Engineering from Texas A&M University in the United States, as well as BS and MS in Industrial Engineering and Management from National Chiao Tung University in Taiwan. Professor Chen's research focuses on green supply chain management and mathematical formulation using mixed integer programming. He has contributed significantly to the field of industrial and systems engineering through his research and practical applications. As a respected professor, Professor Chen is dedicated to sharing his knowledge and expertise with students, preparing them for successful careers. His research has been published in numerous high-impact journals, making him a leading expert in industrial and system engineering. Let us give a round of applause to Professor Ping Sun Chen.
talk about my research. Today I will give a talk about my research topic is application of smart healthcare and smart medical step scheduling system. So today my outline will, the first one, I will introduce the medical step scheduling problem. So then I will propose a structure or framework for the smart medical step scheduling system. Then I will provide, we deliver one methodology for the smart medical step scheduling system. Then we build a prototype for a smart medical step schedule system, then made a conclusion about my talk. And for my research, I use the operation research, or we can build out a mathematical model or in the green supply chain or in the healthcare application or in industry application. And for healthcare application, I use some statistics and system simulation accumulation, and some algorithm to solve this mathematical problem and do the research. And for healthcare, as an industry engineer, this is for the cross-discipline area for the industry engineer. So before we do this research, we need to have a resource to access this data. So the first one, we need to build up the collaboration with the case hospital. Like when I was a postdoc in National Cheng Kung University, so we build up the relation with the director of the imaging center, so I can have the interview with him and his team. So when we construct a cross-discipline team, then we can do the interview because we need to extract the domain knowledge from the hospital manager. So then we need to make sure the full cooperation among the team members because we need to interview with them for their knowledge, especially for the scheduling, how to make the appointments or patient appointment scheduling, or how to arrange the nurse scheduling problem. Then we can analyze and discuss the result with the team member so we can make sure the proposed method is possible to be implemented in the case hospital. Then we can summarize some hospital managerial implications. And for the medical or staff scheduling problem is a traditional problem in the operation research since the 1970s. So there's still many publications in this area. So right now, we have already know medical staff scheduling issue is a NP-hard problem, which means when the problem scale goes up, the solution time will become the exponential growing. So which means if you use the mathematical software to solve this problem, when the nurse scale is larger, so it's difficult to obtain optimum solution within the reasonable times. And the challenging problem for the medical staff scheduling is because of the rotation of the shifts. Because the hospital, they usually run 24 hours a day. Then they can be divided into 3 shifts a day. Each shift has 8 hours. So for the scheduler, they need to assign the day shift, evening shift, and night shift for the medical staff. But they also have some regulation for the government and for the hospital. For the government, they require, because we need to take care of the health of the medical staff. So for example, if you arrange one shift for one medical staff, after 8 hours,
he or she need to or take a rest about 12 hours. So you can arrange another shift for this staff. So the problem for the research always focus on how to arrange fairness or the preference to satisfy the customer for the medical staff, or you want to minimize the variation of the preference for the medical staff. And for the framework of the smart medical staff system, we can see the right side. Before we call the smart system, which means this is the schedule can generate by the machine or generate by the computer. Or we want to generate monthly staff schedule automatically, but we need to input some data. The first data we need to we call medical staff pre-shift, or some medical staff it may be 1 day off in advance for next month because he or she maybe have the family trip. Then second one, you need to have the hard constraint, and we also call the soft constraint in the mathematical model. And for the hard constraint, they come from two parts. The first part from the hubs or the government regulation. Then every country has different regulation. So when we do the schedule, we need to customize to follow each regulation of the country. Then second one, for the hospital regulation, or different hospital have different policy. So during here, we also need to do customize for the regulation. So we need to have two kinds of the regulation, and each regulation we cannot be variate. We need to follow all of the regulation. So we call the hard constraint. Or the solution must obey all of the them constraints. And second one is called the soft constraint. There's a different situation for the mathematical model. Because for mathematical model, we always call the constraint. But in this problem, we have the two kinds of constraint. For the soft constraint, we can violate, but we don't want, or we want to follow all of them. But if impossible, sometimes we can violate the soft constraint. But if we violate the soft constraint, then will cause the penalty. So we want to minimize this kind of the penalty. So objective function will be minimize this kind of the violation or the soft constraint. And soft constraint is related to medical staff preference. They also need to customize by different medical staff. So if we can build up the mathematical model, so you have two kinds of choice to solve the problem. One is the use the mathematical software. So you need to buy the mathematical software. Then you have the knowledge to write the mathematical equation, then implement the mathematical software to solve the problem. Then this kind of system we can call a smart medical staff scheduling system, because after this kind of mathematical model and solution, we are general optimum solution for the schedule. And the other way, you can also deliver the code by yourself or by your team. So we can use the meta heuristic algorithm. They also many meta heuristic algorithm published in the paper. So second way, you don't need to buy the software, but you need to have ability to write the coding to solve the problem. And if you implement the coding, they also become your core methodology for this smart medical staff scheduling system. For a mathematical model, we need to have the objective function. So here we want to minimize the violation of the medical or staff or prevalence. Then we have the constraint or for the hard constraint and soft constraint, or two kinds of constraints. And for objective function, the first we need to associate with the soft constraint. So we need to calculate, or we need to evaluate the soft constraint weight. So here we use the analytical hierarchy process AHP method to extract the weight, to calculate the weight. So we design the questionnaire and distribute this questionnaire to the medical staff. We use a case study. So in this case, we have 7 sub-constraints. We interview the medical staff. So we find they have 7 kinds of the sub-constraints. And after AHP analysis, we calculate each weight of the sub-constraint. Then we can find the most important weight is focused on the day of behavior or day of shift pattern. And for the difficulty for scheduling is sometimes how to make up your constraint. And when during the interview, the scheduler may give you, I do the schedule, monthly schedule by this way. And then if I have the one version, then maybe I public, then the medical staff will come to me and say he want to change during some schedule or for some shift on certain day. So this is the difficulty you extract the knowledge, the domain knowledge for the scheduling. So I do the color. So after the hard constraint, actually they come from the hospital side regulation and come from the government side regulation. So you can see for the first one is the every shift or every medical staff every day they have 4 kinds of the situation. They can be assigned a day shift, evening shift, and night shift, and all day off, or one of the situation. Then for the blue color, which means is the regulation by hospital, or hospital may be required a certain number of medical staff in certain units. So this depends on each hospital situation. The next one, the non-medical staff can have a consecutive day off over the 4 days. This is the rule for the hospital. Actually, we can do some exception, or because sometimes for emergency situation, so this one maybe can be skipped. But this is the rule by the case hospital. And for the red color is for the government, or for example, each medical staff must have a day off during the consecutive 7 days. And they also have, I mentioned, every shift, then on the one day, the following shift must over the 12 hours. You can assign another shift. So for the soft constraint, we have 2 kinds of the soft constraint. One is we call shift pattern, and one is called the day of pattern. Here, the shift pattern, actually, they are feasible, but not preferred by the medical staff. This is the difference from the hard constraint. Hard constraint, which means you cannot violate this kind of the constraint. But for the soft constraint, which means the medical staff, they did not like this kind of the shift pattern, but actually is legally. So for the motivation, and we already tried some meta-heuristic algorithm. Actually, we did not get a good job or compared to the mathematical software. So this is why we
need to provide our methodology to try to improve the solution quality. For the operation research, this is the ultimate question. So you can two ways to improve your research result. One is solution quality, one is the solution time. In this research, we focus on research or solution quality. And for the meta-heuristic algorithm, usually they will say we have an initial solution that is random general. Then you can use the meta-heuristic algorithm to try to improve or iteration by iteration. Finally, you will get a near optimal solution. And for the local search during the iteration, you maybe decide different local search, and usually like just random or local search. This is the traditional way. So in this research, we design two kinds of the heuristic algorithm to solve the initial solution and for the local search. The first one we call the decision tree or method for the initial solution, and one is for the greedy research or greedy search algorithm for local search. And so for the shift pattern, we use a decision tree. If we assign a medical staff, the first day we give the day sheet. The second day they have 4 possibilities. And you can see for the, if the first day is day sheet, the second day is day sheet or day off, they don't have any penalty. But if the first day is day sheet, then second day is evening sheet and night sheet, they will have violate the self-control. That will cause the penalty. So we can continue to the third day and fourth day. Then we try to find a rule. Then we extract the rule for our initial solution. So for the second evening shift pattern, we can see the evening shift. If the first day, then second day evening shift or day of shift, they don't have the penalty. But if for the evening shift for the first day, then day shift for the second day, they will violate the hard control, which means they cannot allow this kind of pattern. But if for the evening shift first day and night shift second day, they will violate the self-control, which means they will cause the penalty, but it's legally. Or similarly, for the night shift, they can see they have 2 kinds of violation. So they maybe only have 2 choices for the second day. Only can be night shift and be day off. At this kind of the decision tree, then we have the 4 rule. Then this kind of rule we design into the initial solution. So we can see for the when we have the previous day and current day, they have different sheets. Usually they will cause the penalty. So this, when we generate initial solution, we can avoid this kind of situation. Then they will second rule, they will reset if they have the 1 day, 4 day off. They become the first day. No matter day off is on day 3 or day 4. If we have the day off, they become the day 1. So this kind of the rule, when we have the rule from the decision tree, then we can decide for the initial solution. The second one, we want to minimize the objective function value. So we call the local search and we use the greedy, which means if after initial solution, we have violated some self-control, then we can see their weighting. So we have 7 kinds of the self-control. We do the sorting from the largest weight to the smallest weight. So we can see the constraint 6 jump to the first, then follow the constraint 7, constraint 4, and constraint 5. Or they have the most weight. So we use the flow chart. So when we have this kind of the violation for the constraint 6, then we will fix them how to fix, we just do the exchange of the two sheets between two medical staff. So if we can fix, we can reduce the cost. Of course, sometimes when you rearrange the sheets, you may be avoided or sub-constraint for constraint 6. It may be caused or variation for the other constraint. So we just try to do this kind of local search, and we want to find a minimum solution. And these two kind of heuristic algorithm, actually we want to compile the traditional meta heuristic algorithm. So in this paper, we try to combine with the PSO algorithm and BET algorithm. So for the initial solution in the shooter code, like the line 4, the red color original is generated by random solution. So this is here, we just replace by the decision tree. Then the method, we have the 4 rules. And for the search procedure, traditional PSO or shooter code on line 21, they just do the local search. Then here we replace by our greedy search algorithm. So we use the testing data, and then we try to find our algorithm can converge to the near optimum solution after the 400 iterations. So actually, I just show 2 examples or 2 runs. We can see the dot line or blue dot line or red dot line actually is close to the optimum solution. The optimum solution value by mathematical software is 0. So you can see in the long run, they will close to the 0. Then we test the 2 kinds of the data set. One is the regular or only 10 or 9 to 10 or medical staff. And for the second column, this is the optimum solution by mathematical software, which means 0. Which means they can generate output of the schedule without any sub-constraint of the medical staff preference. And for the green column, which means this is the traditional BET algorithm without our algorithm. So you can see the penalty is the median, or just like a 7 to the 8 range. There's the average data is 30 or testing data. So we calculate the average function or objective function and standard deviation of each case. Then you can see the yellow one, which means we only implement one kind of the method in our algorithm. Then for the red one, we input both algorithms at the same time with the BET algorithm, which means it's very close to the optimum solution. The value is 0. So for the average objective function value and standard deviation value is very small, which means represent the robotics of this kind of 2 algorithm. Similarly, we also combine 2 heuristic algorithms with the PSO result. We can see for the different data set, we still can test it the result for the both algorithms. The value is close to the 0, and standard deviation is also very small. And for the largest case, because we do the research, we do the literature review, we find currently in the paper, most largest case is about 38 medical steps. So we test the larger scale of case for our algorithm. Then here we can see for the optimum solution by mathematical software, sometimes they cannot be 0, but close to 0. And during this case, if we only use the traditional algorithm, meta algorithm. Sometimes they cannot find the solution within the reasonable time. They must apply one of the algorithm we provide or both algorithms we provide. So you can see after both algorithms, during the large scale size, we can find the solution close to the near optimum solution. So the next part, I will introduce the prototype for the smart medical step scheduling system. After we have mathematical model, after we have delivered our meta-heuristic algorithm, so we have the core method to solve the problem. So we use the PHP to deliver this kind of prototype system. So the user can select the hard constraint they want, or for this case, they maybe only choose the 4 hard constraint they accept or the hospital or regulation. Then for soft constraint, they also can check the 7 soft constraint by the user. Then user can select or pre-schedule or pre-shift for some medical step on certain day on certain shift. So in this structure, we also keep the extension, or in the future, they can write a different algorithm, so they can extend the different algorithm to increase the solution quality or improve the solution or reduce the solution time. So we can finally generate the output by the smart medical step scheduling system, or this by the PHP, then generate the result. We can use the Excel file to present 6 steps or monthly schedule. So we use the color to represent different shifts. The white color represent is the day off. So every day, is say the Sunday, we require the 9 person. So it's visualized or easy to understand, did we satisfy the constraint or we did not satisfy the constraint. So for the conclusion, so this is the key result for this smart medical step scheduling system. We need to extract the hard constraint and soft constraint is ruled by the domain knowledge, or this more difficult path for the scheduling problem. Then second, when we have this kind of domain knowledge, we use the operation research method to write down the mathematical equation. So the third one, we need to have the meta-heuristic algorithm to solve the problem. Otherwise, we just need to buy the mathematical software to solve the problem. Then we do the simple demo for the interface for this kind of smart medical step scheduling system. That's all for my presentation today. Thank you.
Keynote speech on smart healthcare and application of smart medical personnel scheduling system. Your insights and expertise in this area were invaluable and greatly appreciated. Continue inspiring us with your great work. Thank you, Professor. And for our last keynote speaker, Professor Awaluddin Mohammed Shaharun, an accomplished academician with over 40 years of experience in the field. Professor Shaharun holds degrees from Liverpool, Cranfield, and Loughborough Universities in the UK, and his research interests include advanced manufacturing technology and management of technology and innovation. He has published over 100 papers in international journals and conferences and held various prestigious positions, such as the director of the Razak School of Engineering and Technology. Currently, he is serving at the Islamic University of Medina. Professor Shaharun played a significant role in the ABET accreditation of the faculty's programs and set up a master's program in engineering technology and management for industry practitioners in the Manida region in Saudi Arabia. Let us all welcome Professor Awaluddin Mohammed Shaharun.
Okay. Bismillahirrahmanirrahim. Very good morning and Assalamualaikum warahmatullahi wabarakatuh to everyone. Thank you for the kind words of welcome, Mr. Chairman. Let me just share my presentation today. Okay. As an academician, when I was asked to present a paper on the Industry 4.0, I was wanting to pursue this topic, which is basically of interest to me. That is, how do higher education institutions gear or prepare themselves to ensure that they can develop and produce industrial engineering graduates that will have a share, that will have a role in this great revolution that we are facing even today. So I would like to begin by quoting Mr. Richard Riley, the former American Secretary of State, in 2014 when he was addressing this issue of Industry 4.0. And he said that, and I quote his words, we are currently preparing students for jobs that don't yet exist, using technologies that haven't been invented, in order to solve problems that we don't even know what are these problems yet. Very interesting words that has been used by Dr. Riley, because this is the same issue that we as academicians are facing when we are trying to prepare the curriculum which will be used for the next generation of industrial engineers. So by way of introduction, I'll just say a few words here. Today we stand on the threshold of an industrial revolution. It will change the way that we work, that we live, and how we relate to each other. And in the words of Clay Christensen, he says that it will be a period of disruptive innovation. Okay, and this transformation will be something that we have never experienced before, because it will combine, it will integrate digital technologies, human, physical, and even biological spheres within our life. Now, industrial engineers, we hope, will be at the forefront of this revolution. And we will try to see what will be their roles and what will be their needs and how we can try to fulfill these needs in the academic environment. So it's a bit difficult because, you know, when you are looking into the future and trying to answer the question, can we ensure that our IE graduates will find jobs in the future? Can we be guarantee that they'll be able to sustain themselves amid all these rapid changes and challenges? It's a bit like looking into the crystal ball and trying to predict the future, you know? And of course, with technology changes at a very rapid trajectory, upwards trajectory, so this makes any guess just basically at best an educated guess. So anyway, I want to begin by saying that at the moment, we have a limited understanding regarding the skills which an IE engineer requires for Industry 4.0. Now, let me continue by quoting Sutopo, because he explains that industrial engineering incorporates every aspect of management decision, from the shop floor up to the top level management, in terms of planning, organizing, operating, controlling production systems, environmental systems, etc., etc. So that's a very, very huge and very wide area. And Prativi also makes this a bit more clearer because they have said that now, basically, if you look at the direction of industrial engineering, it has gone into about 15 research areas. So he mentioned about materials, operating research, ergonomics, mechanics, product design, supply design, etc. So when you look at this spread, this wide spread of research areas, definitely when we go into the fourth industrial revolution, industrial engineers will play a very significant, maybe even an increasing role in the fourth industrial revolution. So by way of just to explain for some who may not be very familiar, what we talk about Industry 4.0, this is one of the famous diagrams which I reproduced here for your reference. So we have gone through three industrial revolutions. The first industrial revolution was the use of water and steam power. That was in the UK industrial revolution. Then we had the electricity, we discovered electricity, and then we have mass production. So for example, the Ford motor car, so they used the first assembly line to produce cars. Okay, there was the second industrial revolution of mass production and division of labor. And then in the year 2000 and so on, we had the third industrial revolution, where we use the computer systems that can actually automate production. Okay, and today we are in the fourth industrial revolution, because why? Not only that we have electronics, but now we are actually integrating the internet, the physical, the material, the means of production, etc. All are now interrelated, and they communicate to each other seamlessly within the vast universe of the cyber, and things are becoming very complex. So that basically is where we are today, and that's where our children and our grandchildren will be in the future. So when people talk about Industry 4.0, initially there were about 9 areas they mentioned. They talk about physical, the cyber physical systems. These are things that actually communicate through the internet and exchange data. You have, for example, now self-driving taxis, self-driving cars. We have drones, you know. We have intelligent buildings. So those are the cyber physical systems. We also have the IoT, or Internet of Things. That is basically communication devices that communicate, they share information through the internet and so on. Big data, okay, information that basically has a lot of data which is generated, and people try to make sense of this data. 3D printing, or basically one of the additive manufacturing technologies that are now the leading the manufacturing, robotics, simulation, augmented reality. These are basically devices that are used enhance the user's perception when they are dealing with physical situations, cloud computing, so Dropbox and so on, and of course issue of cybersecurity. This is where the problem with respect to hacking and so on. Okay, so in Industry 4.0, you can see here, and I just go through very quickly. One of the important thing is basically data and analytics. So that's the core capability. These are the digitization and integration of the vertical and the horizontal value chains. Okay, they also have products and services, and also models and customer access and so on. All are basically integrated, right? And these are accessed, this data accessed through many mediums, mobile devices, IoT platforms, GPS, human-machine interfaces, system that cybersecurity for authentication, fraud detection, 3D printing, smart sensors, big data analytics, customers, and so on and so forth. So there are a huge sources where this data is being input as well as being output, right? So that's basically the digitalization of enterprise and the digitalization of man's work and even social aspects. So the challenge, therefore, is that as institutions of higher education, we have a very important role in trying to educate and trying to train the new generation. We have to develop, we have to do research, we have to develop new technologies, and we have to prepare these students that are going to go to industry. And therefore, as what Kaitan and Mekali has mentioned, university has to come up with new course contents, which are flexible and adaptable. Because there are changes here, and I will go through some of these changes in my lecture. And lecturers must also find new approaches towards teaching, how to develop course materials, the labs, the practical work, all has to be tuned so that the students have the skills ready for the marketplace. Yeah? So therefore, when they have the skills ready for the marketplace, then these students will become relevant, and we can ensure them a job in the future. The problem is, and what are the problems here? I think this is the issue. The generation that we are talking about now, generation Alpha and Beta, these people, the students have a different, totally different learning styles from the students of yesteryear. Many studies, and I quote these studies here, just for your information, that students tend to learn through many means. Yeah, through heterogogy, which is basically self-directed, so they learn on their own. Pedagogy, they learn among themselves. Cybergogy, they use the internet to look for materials, to enhance their learning and so on. They also have blended learning, where they have face-to-face classrooms and also the internet resources. Some are using WhatsApp, some using devices, using what they call it, Telegram. They are using all sorts of things, even learning through gamification, through games, yeah, Skype, FaceTime, Hangouts, and even all these things. So the students of the future will have basically a different style of learning, and we as academicians, we have to prepare ourselves to face these challenges. Now, in line with this, the lecturers of the future, yeah, the teachers who are in this IR 4.0, so they have to treat education not as just giving what they know, but they have to also learn new skills, yeah, new teaching and learning skills that can adapt to the individual styles and strategies of the students. Okay, lecturers need to be innovative. They need to be on their own. They need to be knowledgeable. They have to be analytical. They have also be willing to try anything new. Okay, in order to capture the students' interest and to promote the learning. And therefore, the OBE, or the outcome-based education, becomes very crucial in the years to come, because at the end of the day, it's not what the lecturers are able to teach, okay? It is what the students are able to master and what they are able to do, their competencies. This is the most important outcome, or the most important end product of education. So this is basically the challenge. Now, oh, I forgot to mention, actually, when we're talking about students' learning styles, here, where is it now? Yeah, many studies have shown that students' actual attention span has actually reduced to between 10 to 15 minutes. That's how long they can focus on education. So in our lectures, normally, our lectures are about 50 minutes, right? Some lectures they take more. So how do you engage the students? How do you capture the attention of the students? How do you make sure that they focus and they learn? This is the challenge. And that's why lecturers need to have these competencies, the engagement to be able to master the skills needed to be the lecturers of IR 4.0. Now, I just did some study about the lecturers themselves from the point of view of lecturers. How ready are lecturers to embrace this revolution? So I just did a rough study in Malaysia, and I quoted some studies here. Lai, Man, Hud Kemri, Zulnadi, Muhammad Ashraf, all these have actually done some research to assess the readiness of the teaching staff and in embracing the IR 4.0. What their findings indicate, I will just roughly mention that at the best in our country, in Malaysia, I do not know about other countries, in Malaysia, the readiness or the ability to embrace this is at best at a moderate level, at best, okay? And many reasons are mentioned about this. Many lecturers, they mentioned that they believe the current infrastructure, the IT infrastructure in our country is not adequate to handle the expectations of IR 4.0. So this is one of the biggest challenge of any country. If we want to go for IR 4.0, we have to ensure that the infrastructure that is required to support the new way of teaching has to be sufficient. And my own experience, I think both myself in my work in Malaysia and also in Saudi Arabia, I think the IT infrastructure are less than adequate. So this does not bode well. Yeah. So I don't know about the rest of ASEAN. So this is just my question which I can throw to you. So how can teaching change in IR 4.0? Again, these are some of the points that have been made. People can learn any place, anytime, anywhere, right? The COVID pandemic has shown us that, yes, it can take place. Yeah? Although we have our own intuitions, our own preferred preferences, but given an emergency, e-learning and so on can take place and to some extent be very effective. The second one, that we have to treat students as individuals. We have to tailor knowledge according to their abilities, right? We have to actually explore possibilities which are unlimited and unrestricted in terms of the hows and whys of education. We cannot have just rote learning. It has to be, in a sense, project-based to enable the students to capture their interest. The students need to acquire expertise in the field that they are going to graduate. We need to ensure that they have creative skills. They need to have analytical skills. Yeah, the way that we assess. So in terms of exam pattern changes will have to be different, and therefore we need to have a comprehensive teaching strategy. Okay. Here, this is maybe I just spend a bit more time here. This is basically the education 4.0. And what they call it, Lizondo and Garcia Reyes, which is a very up-to-date, what they call it, article, gives us a perspective of the industrial and systems engineering education which is required. And essentially, what they do is that they divide into two perspectives. One is basically, they call it the internal perspective, which is basically within the university, or within the academic environment, and the external perspective, basically in terms of where the students are working, the organization, the research centers, and so on. And the curriculum, basically you can see here, they have courses and they have projects, right? We talk about digital transformation strategies, change management, technology management, big data, human resource, supply chains, operation research, project management, and so on and so forth. So that are basically the academic curriculum which is necessary to provide the theoretical basis for the industrial engineering education. At the same time, they talk about skills. They talk about cultural and interpersonal skills, and this involves exposure, okay, international experience, participating in joint research programs, handling diversity in terms of culture and also technological innovations. right? They talk about laboratory practices, and they talk about the use of autonomous robots, additive manufacturing or 3D printing, big data, basically augmented reality, virtual reality and simulation. So these are things that, as you can see here, it can be both within the university or within industry, okay? IR 4.0 can allow students to work, as if that they are working in industry. And then, of course, the other aspect is the club activities. So awareness programs, workshop, webinars, seminars, all these are basically competitions. These are all things that enhance the students' interest. It enhances their exposure, and it gives them a sense of direction where they should go. And of course, lastly, we're talking about the professional experience. Yeah? The working in the smart factories themselves, the professional responsibilities and real life problems and capstone projects. So these are very important. And underneath that, you can see that package basically that what is also required is to work in a multidisciplinary team, to work in a digital technological knowledge, okay? And then it also involves development of competencies and lifelong learning. So this is very, very important for the future. Right. Okay, I don't want to talk here about the changes to Education 4.0. This is more or less the same that I've mentioned before. The transformation in the higher education system will involve various techniques of flipped classroom teaching, e-learning, virtual labs, and project-based. So these are all requirements for the future education system. And the important thing also that I want to mention here, both formal and informal lifelong learning will be crucial, okay? You can see here, vocational training, the wages of people from industry, they can increase if they work within the industry. Graduate schools, in-house, and also the MOOC or the massive open computer courses, right? So there are at least about 58 million people now taking at least one course on MOOC, and then of course self-directed learning. Now, coming back to this, let me just go back to these 4 areas that is important for the engineers of the future. Big data, all right, with everything that is required there. Automation, robotics, smart and embedded systems, and active manufacturing. That's the second one. Third is the up-to-date domain knowledge, all right? And then innovations and entrepreneurship, okay? These are things that enable the students to make designs that can take to the marketplace. So my question, and this is what I just want to share with you, are the universities currently offering the relevant IE courses? So I take 7 universities, 3 from the US, Georgia, Purdue, Gannett, 2 from Malaysia, UTM University, Utah, 1 from Indonesia, ITNS, and 1 from Hong Kong University. And what I did was I just put the one which is in the what do you call it in yellow. These are some of the relevant courses identified for IR 4.0. So you can see obviously from this that the US universities basically capturing the roles and the requirements in their courses. The ones in Hong Kong also doing the same. They even have courses on mobile devices. Okay, these are all IE courses. We have in Indonesia, they have about 3. But the ones in Malaysia, unfortunately, I would say, their courses are the conventional courses. Conventional courses that perhaps you will see this in 1980s, 1990s, 2000, and so on. But they don't have this sort of challenging, interesting, innovative courses. Is it because they don't have the facilities? Is it because that the lecturers themselves do not have this capability? These are questions that we can ask, right? I do not have answers, but what we can say is that if we are going to prepare students for the future, then we need to offer courses that are going to be the currency of the future, right? Not courses that perhaps belong to 30 years ago, that perhaps no longer is as important as these new courses today. So this is the challenge. So my general findings, and I think we can generalize it, universities are still lagging behind. Although the identification of key emerging courses have already been done, many institutions still offer traditional courses, right? Very difficult to make significant changes because of the accrediting bodies and teaching staff are very slow to change, funding, and so on and so forth. So more needs to be done, okay? If we are going to capture the wave, if we are going to be the front, we're going to be in the forefront of the IR 4.0, universities need to look back, see whether their courses are relevant, what can be done, what can be do in order to get on the boat. Otherwise, we get left behind. Whatever we do, definitely we know that students will learn differently in IR 4.0. Okay, the way that they learn will be totally different. The framework for IR 4.0, it will blur the distinction between the classroom and the workplace and the lab. There will be a seamless transition. Okay, there will be no rigid boundaries. Students can access real-time data from the workplace, right? From the internet, they can get information. Industry, they can allow students, they can even propose projects to students, allow the students to design and simulate and test their designs. And if they find that it is good, they can adopt. So there can be actually not just a learning environment, but also a marketplace where entrepreneurship among the students are encouraged to develop their creative activities and at the same time make money. So digital technology will allow the factory to be a teaching and learning place without the students ever learning their classroom. So this is basically the promise of tomorrow. In conclusion, industrial engineers are critical components of the IR 4.0 digital transformation. We need to have, in general, a sea change in curriculum design and implementation to ensure that their skills are relevant in the new environment. Teaching, instructing, and support staff must also show a high degrees of readiness and acquire the skills required to make the transition to IR 4.0 thinking. So with that, I end my my presentation and I welcome any questions. Thank you very much.
Thank you, Professor Shaharun. The organizing committee would like to extend our heartfelt gratitude to Professor Awaluddin Muhammad Shaharun for his enlightening keynote speech on the topic of Industry 4.0, implications to higher education institution for ensuring sustainable IE graduate employability. The audience has gained valuable insights into the challenges and opportunities presented by the fourth industrial revolution and its impact on higher educational institutions. Again, let us give a round of applause for our speakers. So for our speakers on site, let me invite you to the stage for our question and answer portion. Then before we start, I would like to remind everyone to please keep their questions relevant to the topic and respectful and being concise. We want to make sure that we have enough time to address as many questions as possible. So our expert panel is ready to share their knowledge and expertise about the topic they have presented. So without further ado, please begin by raising your hand. And for the one in the Zoom, you can type in your question and we'll do our best to answer that one.
Thank you, the keynotes for interesting speaks. This is the question for Professor Shen. Just wonder, have you had any case in which you couldn't find feasible solutions using your 3D algorithm?
Thank you for the proposed request. Because for the algorithm, the most important thing is to decide a feasible solution. for this kind of the we call the constraint problem, because usually in the beginning, meta heuristical algorithm they only have the objective function, they don't consider constraint. But right now, many mathematical optimization problem we have the many constraint. So I did not mention usually when you have the design like a feasible solution, during the search process, they still become violate the hard constraint. Because during the local search or something, sometimes they still will violate. Then usually for this kind of the algorithm, you need to have repair mechanism to repair the infeasible solution become the feasible solution. So in the paper, we also mentioned how to have this kind of the repair mechanism to make sure the every solution will be feasible solution. Yes.
Any more questions from the audience? So we have one question for Mr. Lin. So since when MTM started to implement sustainability, and currently, what are the impact of it into your company?
Okay, I think for the implication, the ESG or the sustainability is very important. So it will be my customer the policy. So from our policy, we will to every department must to do and have the target and like the i.e. the PDCA, how to plan, how to the target. For example, we from the sales department. Sales department, you how to forecast about the order, about all of the customer the shipping times is very important. Per month, you must ship in the 4 times. You can reduce to the 2 times. I think the truck, the oil, the carbon, and anything will reduce. So the other we also can to discuss with the customer. We can to reduce the carton or the recycled carton. Also can reduce the carbon. Anything, also like the R&D department, you must to have the reduce the carbon sinking in the design. So you can reduce the material, you can to reduce anything. Everyone, we want to thinking how to reduce the carbon. So every department. So you must set up every department the target and how to do, and the per year or per month the performance. I think is very important. So in the near future, all of the international company will ask you to do it. So we must do. If you cannot to do it, you must go out the business. So it's very important. Thank you very much.
Thank you, Mr. Lin, for that answer. Any more from the audience who wanted to ask question?
Okay. First, I want to ask to Prof. Dr. Awaludin. Hello, yes. Okay. To Dr. Awaludin. So, maybe it is a good condition to have education system in the 4.0, but sometimes, yeah, we can see the reluctance to. Usually, it comes from some group. For example, the senior group that maybe often have more difficulties in catching up the technology advance. So maybe you can give us a suggestion how to deal with the certain group. Yeah. Thank you.
Well, Actually, that's a very important question that you posed. How can lecturers, how can educationists prepare themselves? Because at the end of the day, industry expects the higher education institutions to produce graduates that are fit for the job. Now, we faced these problems, before. I remember, my experience in education a long time. In 1980s, when we introduced the computers to lecturers, right? Many of them refused to use the computers. They prefer to just lecture and so on and so forth. It took a long period of education, and you have to change the culture. So university administration has to play a lot of important role here to actually change the mindset of the lecturers so that they are able to face up to the challenges. Many of them have been educated in the traditional way. Their curriculum in the industrial engineering are still basically what they have studied maybe 20 years ago. And those are basically maybe not relevant for today. So either they change, okay, and this is the challenge, either they change or they have to be changed. In other words, if they refuse to change, then we have to find someone or some people who can actually do the job. Now, the challenge, I think, in doing this is that there is an urgency, because most governments, and I think I'm talking on behalf of ASEAN, almost all the governments are actually gearing up for 4.0, IR 4.0. So the imperative is the higher education institution, in order to be relevant, will have to change the way they teach, what they teach, and where they teach, and how they teach in order to be relevant. And because we also now have a system of international rankings, which we didn't have before 30 years ago, so you can see where you are. If, for example, you do not unable to keep up with the change in technology, the change in the educational requirements by industry. And what you will find is that your graduates will be the least employable. So the educationists or people who are in the business of teaching have to understand that this is not just a change for themselves. This is a change that is required for their organizations and for the future of the students, because students can choose now. They can choose to go wherever they like, whenever they like to study. So it is no longer a captive market. So if we want to survive, we have to change. I think that's my message to educationists. Thank you.
Thank you, Professor Shaharun. So I think that ends our Q&A session since we have a limited time. So for our global summary, to sum it up, these topics highlight the importance of technology in improving efficiency, productivity, and sustainability across industries. The concept of industrial smart manufacturing and sustainable development strategy involves utilizing advanced technology to optimize manufacturing process and reduce waste, leading to greater resource efficiency, lower carbon footprint, and better financial outcomes. Additionally, smart healthcare applies technology to healthcare to improve patient outcomes and reduce costs, such as through smart medical personnel scheduling system that optimize resource utilization. The implementation of Industry 4.0 has significant implication for higher education institutions, enabling graduates to acquire the necessary skills to succeed in a rapidly evolving job market and contribute to the sustainable development efforts. Embracing technological innovation and sustainability can lead to progress and improved quality of life for all. Again, we would like to thank our distinguished keynote speakers. Thank you for your time and effort. And now I will give the floor to Rihanna. Rihanna, take it away.
Thank you, Clint. And I would like to thank you for the keynote speakers, and you may be seated again. And I would like to ask the ushers to remove the table and also the chairs from the stage. That is the end of keynote session. I would like to thank once again all keynote speakers and moderators. On behalf of the entire ECM committee members, I want to thank you for your intuitive presentation. All participants got a lot of information and inspiration from you all. As an honor of appreciation, we would like to invite Professor Wei Jungxiang and all keynote speakers and moderators to come forward on stage and receive the appreciation of honor. Professor Wei Jungxiang will give the token appreciation to all keynote speakers. Thank you, Professor. First of all, to Professor Ping Sun Chen, or maybe Stephen Lin. This is the same, Professor. Give applause. Take picture. Thank you for Mr. Stephen Lin. And now for Professor Ping Sun Chen. And now photo session. And lastly, for Professor Awaluddin. But before we take a picture here. Okay, thank you, Professor Xiang. And now for Professor Awaluddin, we want to thank you very much for your presentation, which is very insightful and very useful for the movement of the industrial engineering education curriculum in higher education. Thank you very much. Big applause for Professor Awaluddin. And now back to Jakarta. Yogi, most welcome.
Thank you, Rihanna. Thank you and many grateful to all moderators of keynote session, and special thanks to our honorable all keynote speakers of 14 ECM 2023. Ladies and gentlemen, the briefing works today program, we do hope you have absorbed important and core information that we can share back home to make better future. And we thank you for participating in the program. Back to Taiwan, Rihanna.
Okay, and we have now come to the last session, which is the photo session. There will be 3 photo sessions taken. First, for the audience at on-site Indonesia that will be navigated by Yogi, and also for the audience now at on-site Taiwan, I would like to invite the ushers to guide the participants to come forward at the seats to fill in the front seats first. And I invite the photographer to come forward to the stage. And I invite all guests who are still sitting in the back part of the podium to come forward so we can take a picture together from the photographer towards the participants who are sitting down.
Okay, ladies and gentlemen, and honorable guests, before we close keynote session, we would like to invite all the participants in Grandia, Jakarta, to come forward to be taken our pictures, and to the committee, please make arrangement for the session. Thank you.
And also there will be a photo session for all Zoom participants for this session. And I will invite all participants to open the camera, and I will ask the help of Mas Daniel or Mr. Katon in Jakarta to take the Zoom pictures for all the Zoom participants. To the participants in Taiwan on site, there will be lunch and snack box outside the lecture hall. And for the respected guests from Thailand and also professors, will be guided to the lunch room with Elsa. Thank you, participants and honorable guests. At 2 p.m. Taiwan time, there will be an on-site presentation in this lecture hall, and I will invite you to come back at 2 p.m. after the lunch break. And also with the Jakarta on-site, there will be 1 hour break, 12 p.m. Jakarta time, and it will start at 1 p.m. There will also be sessions in breakout room for the online presentations. Thank you.
Thank you, Rihanna. The parallelization presentation will be started at 1 p.m. local time in Jakarta, Indonesia, or 2 p.m. Taiwan time. The presenters should be ready before the time because we have a tight schedule, and please join on time. Ladies and gentlemen and all participants, thank you very much for your kindly attention participating in the program, and keep healthy protocol. Good day and happy presentation. Thank you and see you in parallel session. Please, Rihanna.
Thank you very much, Yogi. And now the participants in the Jakarta site and also in the Taiwan site are most welcome to have lunch and also prayer time. Thank you for your time and also your valuable insights for every keynote speakers given today. I hope all the presentations will be useful for our daily life and also for the progressive increase of industrial engineering and management. Thank you, everybody.
Thank you, everybody, and good time.
Thank you, Jakarta. Presentation in Jakarta and also in Taiwan, also in the breakout rooms. Have a nice lunch, everybody.